Hello students, welcome to the 7th video lecture of Digital System Design subject. I am Lalit Jain, Assistant Professor, Electronics and Communication Engineering Department of Oriental College of Technology, Bhopal. In the 6th video lecture of Digital System Design subject, we discussed about conversion of decimal number system. So today we will learn about conversion of hexadecimal number system. So let us begin with converting hexadecimal number into binary number system. For this, we need to understand the table which is shown here. How the hexadecimal number can directly be converted into equivalent binary number. So for this, we can apply or we can go with one trick. The trick which I basically follow is that you need to start counting from 0 and reach to 1111 and take only those numbers which contains zeros and ones, so that you can have all possible binary numbers of 4 digits. So let me start with 0000. So after 0, 1, 10, 11, 100, 101, 110, 111, 111, after that 1000, 1001, 1010, 1011, 1100, 1101, 1110, and the last is 1111. So by this way we can find out all possible binary numbers, but actually the binary numbers cannot be pronounced like 1, 10, 11, 100 and so on. It can only be pronounced like 0000, 0001, 0010 and so on. So this was just a trick to remember how the binary number can be equivalent with hexadecimal number system. Also you need to understand from 0 to 9 the binary numbers are given, but after the 9 for hexadecimal number, instead of writing 10 or 11 or 12, we need to write the characters in the form A, B, C, D, E, F, and the corresponding binary number is also given here. Right. So let me start with 7C.36, which is the hexadecimal number. We need to convert this number into binary. So directly by making the pairs of 4 binary number, we can convert the given hexadecimal number into binary. For example, 7 is equivalent to 0111. So as you can see, 7 is equivalent to 0111. C is equivalent to 1100. 3 is equivalent to 0011 and 6 is equivalent to 0110. So by this way we can get corresponding binary number. Here we need to convert hexadecimal number system into octal number system. So the procedure is also quite easy. You just need to convert the given hexadecimal number with its corresponding binary number, as we have done in the previous slide. So in this process, 1 will be corresponding to 0001, then 5 will be corresponding to 0101, B is corresponding to 1011, 3 is corresponding to 0011, and C is corresponding to 1100. For checking purpose, you can follow the table which is shown in previous slide. So this was the table. By following this table, you can convert any hexa into binary or binary into hexa. So the next step for this particular numerical is that, as our task was to convert the hexadecimal number into octal number system, so then after getting the binary number, you need to make pairs of 3 binary bits, because each and every octal number is equivalent to 3 binary bits. So you need to make the pairs. You need to make the pairs. For integer part, you need to move in this direction and making pairs of 3 binary bits. For fractional part, you need to move in this direction and making the pair of 3 binary bits. By this way, you can convert the given binary number into octal number. Ultimately, our main aim was to convert the hexadecimal number into octal number. So this is the similar process. So as you can see, 000 is equivalent to 0 by this table. You can check. 101 is equivalent to 5 and 011 is equivalent to 3 again 3, 0, 0, 1 is equivalent to 1, 1, 1, 1 is equivalent to 7, and then 0. So this is the process how we can convert the given hexadecimal number into the octal number. So this is our final answer. The next is to convert the given hexadecimal number into decimal number. So again the process is similar. First of all, need to convert the given hexadecimal number into binary. So after that you will be able to have this particular binary number, and as we have already done, we have already converted the given binary number into decimal number system just by multiplying the weights of binary. I mean positive powers will be multiplied with the integer part, and the negative powers of the binary will be multiplied with the fractional part. Fine. So by this way you will be able to have final answer. So this will be the decimal part. So here, as we have gone through the conversion of binary number system into other number system, conversion of octal number system into other number system, conversion of decimal into other number system, and also the hexadecimal into other number system. The one trick which you should follow is that whenever someone is asking to convert the number system into other number system, first of all convert that number system into binary, and after converting that number system into binary you can go for any kind of number system. So this is the trick which you should follow. In this slide, as you can see, the another method to convert the hexadecimal number into decimal number just by multiplying the weights of hexadecimal. That is, first of all you need to break it in integer part and fractional part. The integer part will be multiplied with the positive powers of 16, and fractional part will be multiplied with negative powers of 16, and after that you will be able to have 480.164 as a decimal number. So tricks for converting the decimal number into any other number systems are that for integer part, repeatedly divide the integer part of decimal number via r, the new radix, until the remainder is less than the divisor. For fractional part, repeatedly multiply the fractional part of given decimal number with the new radix number, and also apply the procedure as studied earlier in the previous video lectures. Now here we need to convert 557.52, which is the decimal number, into the number which have base 5. So for this we need to understand that the 557 will be divided by the base 5. So this is the process for integer part. For integer part, actually just a minute. For integer part, actually this 557 will be divided by 5, and after getting remainder 2124, so those reminders will be counted from bottom to top. For fractional part, that is 0.52, 0.52 is the fractional part that will be multiplied with 5, and you will be able to have 2, 3. So that will be counted from top to bottom. After that you will be able to have 4212.23 as a base 5 number. Tricks for converting any other number system to decimal number system. So the process is to multiply. Let you want to convert 4212.23, which has base 5, into decimal number system. So you just need to multiply the weight of 5 with its corresponding number. So you need to multiply the weight 5 or positive power of weight 5 with the integer part, that is 4212, and negative power of 5 with the fractional part, that is 0.23. So by this way you can directly convert the given number into decimal number. Other conversions are like determine the values of base x. Here is the question. 211 is the number having base x. We need to find out the value of base x, and that should be equivalent to 1528. So the procedure is quite easy, as we have already understood that how the base value can play a very big role. So here the base value is x, and x base value will directly be multiplied with its corresponding bit. 1 is the LSB and 2 is the MSB side. So MSB side will directly be multiplied with x to the power 2, then 1 into x to the power 1, then 1 into x to the power 0. So this is the left hand side, and for right hand side also 8 will be multiplied with 152. That means a to the power 2 will be multiplied with 1, that is MSB side, and 2 will be multiplied with a to the power 0, that is LSB side. So after that you will be able to have, after solving this quadratic equation, you will be able to have x equals to 7. Other conversions are like 193, we need to find out the value x. So the procedure is similar, but also in this procedure we can check our answer by our own method. So as the answer is 196, that is hexadecimal number, and that is equivalent to 623, which is octal number. So also 193, which is the hexadecimal number. So as you can see, 193 hexadecimal number is equivalent to corresponding binary, and after that these binary can be shared in the pair of 3 binary bits, and corresponding to 3 binary bits the octal number can be found, that is 623. So 623 is similar as 623. For arbitrary number system, find out the decimal equivalent of 1 to lm.l1 having radix or base 5. So the procedure is quite easy, but here we need to assume the value of L and M. Let the value of L and M are 3 and 4. So again, by the process which we have already studied, we can convert this number into decimal number system. So this is our final answer. The process is just similar as we have discussed in the previous slide. So that's it for this particular video.